Okay, hi, I am Naya Maitland, and me and Elizabeth Grace have created a moving man lab report. And our moving man is this guy right here. Okay? So in after I've shown you our PowerPoint for how you would go on with your lab report, then we'll come back and I'll give you an example of how to use this man. Okay? Now let's go to the PowerPoint. Okay, so the moving man. So, your learning objectives for this lab report will consist of creating a position versus time, velocity versus time, and acceleration versus time graph for a man moving in a straight line. So what we just saw before was a man on a ruler, and we're going to try and move him back and forth left to right and figure out what would be his position, his velocity, and acceleration for each time, and create a graph from it. Then, understand the relationship between the three aspects of one-dimensional motion, which is position, velocity, and acceleration. So your setup would look at the end, would look something like this. Except you would have an acceleration versus time graph in the bottom. There's supposed to be 3 here, but there's only 2. Sorry. Now, when you're doing your lab, you should really consider what will be the independent variable in experiment 1 and in experiment 2. Is it possible to have only one dependent variable? What does the system consist of? How can you prove that an object isn't at a constant velocity using acceleration or position? And how can you prove that an object is accelerating using velocity or position? So, for your purpose, your overall purpose for this lab would be to determine the relationship between position, velocity, and acceleration with respect to time for an object moving at a constant velocity and accelerating object. Experiment 1, your object moving at a constant velocity, which is the moving man. Will the position, your questions you would have to focus on would be, will the position increase, decrease, or remain the same for an object at a constant velocity? Will the change be constant? This is an overall question for your whole experiment, alright? And your second question would be, will the acceleration increase, decrease, or remain the same for an object at a constant velocity? Will the change be constant? So at the end of your lab report for experiment number 1, you would have to come back to these questions and see if you solved these questions. Then, in experiment 2, you have an accelerating object, so the moving man will be accelerating. Will the position increase, decrease, or remain the same for the accelerating object? Will the change be constant? And will the velocity increase, decrease, or remain the same for an accelerating object? Will the change be constant? These are the questions you would have to refer to at the end of your lab report to make sure that you have understand and have answered these questions. So, at the end of your lab, your post-lab analysis, we will be constructing a position, velocity, and acceleration versus time graph for each experiment. Alright? Now, for experiment number 1, object moving at a constant velocity, you have an overall purpose to focus on. It is to determine the relationship between position, velocity, and acceleration with respect to time for an object moving at a constant velocity. Questions you would have to answer for your lab report for experiment number 1 would be, what is the net force when the man is moving at a constant velocity? When the man is moving to the right, does his position increase, decrease, or remain the same on the simulation graph? Is the velocity on the simulation graph changing? While the man is moving at a constant velocity, is there an acceleration acting on the object? From the graphs constructed, which slope is constant, increasing, or equal to 0? For these questions, you'll also have tasks that goes with lab report experiment number 1. And I would prefer you do the task first so that you can come back to the questions and answer them. These tasks for experiment number 1 will be define constant velocity, create a position versus time data chart, 5 trials including 0.0 seconds, yes, you have to round it to 10th place, write an equation to find the velocity of the object at the different positions. So this will help you solve for velocity and create a velocity versus time data chart. And in the end, from the givens from the data charts, construct a position, velocity, and acceleration with respect to time graph. For experiment number 2, you'll have an accelerating object, which is the man will be accelerating. Your purpose for this experiment is to determine the relationship between position, velocity, and acceleration with respect to time for an accelerating object. So your questions for this experiment will be, does the position of the man increase, decrease, or remain the same as he begins to accelerate? Is the change, if any, of the position constant? Does the velocity increase, decrease, or remain the same as the man begins to accelerate? Is the change, if any, of the velocity constant? And from the simulation chart, which graphs are constant or increasing? So, for your task for this experiment as well, as I said before, you should do your task before you do your question, so they help you solve for your questions. They would be to find acceleration, create a data chart for position versus time and velocity versus time, starting from 0.0 seconds and ending at 5 seconds. I will show you how to find the time section on the graphs when we go back to the simulation. Also, write an equation for acceleration. Solve for acceleration using the equation above and the data from the charts. Create graphs for position, velocity, and acceleration with respect to time. This last question would also help you with the last question. This last task will help you for the last question. Now, if you want to see an example for the velocity, if you have constant velocity, now this is an example without me solving or anything. I'm just plugging in numbers. You do not have to do this. You have to solve for a number for the velocity. So I put 2 meters per second, and now I'm going to press play. Do you see how the graphs change? That's how your graphs would have to look when you're doing it. If you have to look at it closer, you would have to press follow my pointer and go to the bottom section and press increase until when you look at the time section on the bottom here, you see 0, 1, 2, 3, 4, 5. This is the time I want you to follow on your lab report. And if you look closer, it helps you see what the graphs will look like in the end when you do your project. Now, this is just for constant velocity. For acceleration, it should look something like this. Now, I would clear this, bring this to 0, bring this to 0, the position at 0, the velocity at 0, and the increase to acceleration. I don't know, I'm throwing in 2 right now. Do you see how, and I just paused it, do you see how the graphs look at position versus time, velocity versus time, and acceleration versus time? This is what your graph should look like for your lab reports. And hopefully they will be when you do your experiment. Now, in the end, you might have your position should not look anything like this. I hope it does not look like that. Okay? Because then you have done something wrong, and I hope that the questions and tasks have gotten you to a place where you have done something sort of like in the beginning when I did it. Alright? So that's my lab. This is mine and Elizabeth Grace's lab report. I hope you do it well and you understand what happens.